Today we are going to learn how to use an 8-channel relay with an ESP32 and an I2C LCD to show if lights are on or off.
Hi everyone, and welcome to another episode of Building from Scratch. As you know, my name is Richard. This is part 9.3 of the automation houseboat build. In this little episode, we're going to do a I2C LCD connected to a ESP32 and an 8-channel relay, which we're only going to use 4 channels for this. And the only reason we're hooking them up is so that you can see everything is working right. This is going to be using Alexa without any third-party apps like Synric, Blink, Google. Other than that, in our upcoming episode, we're going to actually be hooking up 4 LCDs, I2C LCDs, all with the same address. But we'll get into that. Keep an eye out for our next episode. You guys have a great day. Jody. Joey, take it away.
Jody? ESP32 I2C Communication, set pins, multiple bus interfaces and peripherals, Arduino IDE. The ESP32 has 2 I2C bus interfaces that can serve as an I2C master or slave. We'll look at the I2C communication protocol with the ESP32 using Arduino IDE, how to choose I2C pins, connect multiple I2C devices to the same bus, and use the 2 I2C bus interfaces. We'll cover the following concepts: connecting I2C devices with ESP32, scan I2C address with ESP32, use different I2C pins with ESP32, change default I2C pins, ESP32 with multiple I2C devices, same bus, different addresses, same address, ESP32 using 2 I2C bus interfaces. We'll program the ESP32 using Arduino IDE. So before proceeding with this, you should have the ESP32 add-on installed in your Arduino IDE. Watch part 9.2 to install the ESP32 on the Arduino IDE if you haven't already. Introducing ESP32 I2C Communication Protocol. I2C means inter-integrated circuit. It's pronounced I2C, and it is a synchronous, multi-master, multi-slave communication protocol. You can connect multiple slaves to one master. For example, your ESP32 reads from a BME 280 sensor using I2C, and writes the sensor readings in an I2C OLED display. Multiple masters controlling the same slave, for example, 2 ESP32 boards writing data to the same I2C OLED display. We use this protocol many times with the ESP32 to communicate with external devices like sensors and displays. In these cases, the ESP32 is the master chip and the external devices are the slaves. ESP32 I2C Bus Interfaces. The ESP32 supports I2C communication through its 2 I2C bus interfaces that can serve as I2C master or slave, depending on the user's configuration. Accordingly to the ESP32 datasheet, the I2C interfaces of the ESP32 support: standard mode, 100 kilobits per second; fast mode, 400 kilobits per second; up to 5 MHz, yet constrained by SDA pull-up strength; 7-bit/10-bit addressing mode, dual addressing mode. Users can program command registers to control I2C interfaces, so that they have more flexibility. Connecting I2C devices with ESP32. I2C communication protocol uses 2 wires to share information. One is used for the clock signal, SCL, and the other is used to send and receive data, SDA. Note, in many breakout boards, the SDA line may also be labeled as SDI and the SCL line as SCK. The SDA and SCL lines are active low, so they should be pulled up with resistors. Typical values are 4.7 k ohm for 5 volts devices and 2.4 k ohm for 3.3 volts devices. Most sensors we use in our projects are breakout boards that already have resistors built in. So, usually, when you're dealing with this type of electronics components, you don't need to worry about this. Connecting an I2C device to an ESP32 is normally as simple as connecting GND to GND, SDA to SDA, SCL to SCL, and a positive power supply to a peripheral, usually 3.3 volts, but it depends on the module you're using. When using the ESP32 with Arduino IDE, the default I2C pins are PO22, SCL, and PO21, SDA, but you can configure your code to use any other pins. Scan I2C address with ESP32. With I2C communication, each slave on the bus has its own address, a hexadecimal number that allows the ESP32 to communicate with each device. The I2C address can be usually found on the component's datasheet. However, if it is difficult to find out, you may need to run an I2C scanner sketch to find out the I2C address. You can use the following sketch to find your device's I2C address. There is a link to this sketch in the description below. You'll get something similar in your serial monitor. This specific example is for an I2C LCD display. There will be either 0x27 or 0x3F. In some cases, you can change the address. Use different I2C pins with ESP32, change default I2C pins. With the ESP32 you can set almost any pin to have I2C capabilities, you just need to set that in your code. When using the ESP32 with the Arduino IDE, use the wire.h library to communicate with devices using I2C. With this library, you initialize the I2C as follows. Wire.begin I2C_SDA, I2C_SCL. So, you just need to set your desired SDA and SCL POs on the I2C_SDA and I2C_SCL variables. However, if you're using libraries to communicate with those sensors, this might not work and it might be a bit tricky to select other pins. That happens because those libraries might overwrite your pins if you don't pass your own wire instance when initializing the library. In those cases, you need to take a closer look at the .cpp library files and see how to pass your own 2-wire parameters. For example, if you take a closer look at the Adafruit BME280 library, you'll find out that you can pass your own 2-wire to the begin method. So, the example sketch to read from the BME280 using other pins, for example, PO33 as SDA and PO32 as SCL is as follows. Let's take a look at the relevant parts to use other I2C pins. First, define your new I2C pins on the I2C_SDA and I2C_SCL variables. In this case, we're using PO33 and PO32. Hashtag define I2C_SDA33, hashtag define I2C_SCL32. Create a new 2-wire instance. In this case, it's called I2C. This simply creates an I2C bus. 2-wire I2C equals 2-wire 0. In setup, initialize the I2C communication with the pins you've defined earlier. The third parameter is the clock frequency. I2C.begin I2C_SDA, I2C_SCL, 400,000. Finally, initialize a BME280 object with your sensor address and your 2-wire object. Status equals BME.begin 0x76, NE2C. After this, you can use the usual methods on your object to request temperature, humidity and pressure. Note, if the library you're using uses a statement like wire.begin in its file, you may need to comment that line, so that you can use your own pins. ESP32 with multiple I2C devices. As we've mentioned previously, each I2C device has its own address, so it is possible to have multiple I2C devices on the same bus. Multiple I2C devices, same bus, different addresses. When we have multiple devices with different addresses, it is trivial how to set them up. Connect both peripherals to the ESP32 SCL and SDA lines. In the code, refer to each peripheral by its address. Take a look at the following example that gets sensor readings from a BME280 sensor, via I2C, and displays the results on an I2C OLED display. Because the OLED and the BME280 have different addresses, We can use the same SDA and SCL lines without any problem. The OLED display address is 0x3C and the BME280 address is 0x76. I2C LCD Basics. This type of LCD is ideal for displaying text and numbers, hence the name, Character LCD. The I2C LCD that we are using in this project comes with a small add-on circuit mounted on the back of the module. This module features a PCF8574 chip, for I2C communication, and a potentiometer to adjust the LED backlight or contrast. The advantage of an I2C LCD is that the wiring is very simple. You only need 2 data pins to control the LCD. Standard LCDs typically require around 12 connections, which can be a problem if you do not have many PO pins available. Luckily, you can also buy the I2C add-on circuit separately on Amazon, so you can easily upgrade a standard LCD as well. If you look closely at the LCD, you can see the small rectangles that form the individual characters of the LCD. Each rectangle is made up of a grid of 5x8 pixels. Later, I will show you how you can control the individual pixels to display custom characters on the LCD. Specifications. The specifications of the 16x2, 20x4, and other sized LCDs are mostly the same. They all use the same HD 44780 Hitachi LCD controller, so you can easily swap them. You will only need to change the size specifications in your Arduino code. These LCDs only have 2 addresses that they come set as. They are either 0x27 or 0x3F. In most cases, this address cannot be changed. If you plan on using multiple LCDs, make sure they have different addresses. In our case, we are using 4 LCDs that have the same address, but we will get into that later. Let's do this with one for now. How to connect the I2C LCD to ESP32S. This wiring diagram shows you how to connect the I2C LCD to the ESP32S. Wiring an I2C LCD is a lot easier than connecting a standard LCD. You only need to connect 4 pins instead of 12. The ground to the ground, the VCC to 5 volts, the SCL to pin 22, and SDA to pin 21. Now remember, the LCD has one address. If you have a sensor that has a different address, then you can still use these pins for that sensor at the same time. This will be demonstrated in another part of this series. Now let's get to the programming for the LCD. Programming the ESP32S with Alexa, 4 relays, and 1 LCD. This is the sketch to start with. As always, there is a link in the description for all of the sketches, drivers, libraries, and anything else you should need. Please watch part 9.2 so that you have everything you need set up in your libraries. Everything we are doing in this video is add-ons to the last one. That being said, let's get to the sketch. Here you can see that we set this up to only work with the ESP32. We are including the Liquid Crystal Display library here. In this line here, we are setting a variable for the Liquid Crystal Display, and tell it what the address is, and the display size. In this case, the address is 0x27, and the display is 20 characters and 4 lines. Next, just like last time, we have set the relay names with their GPIOS, only this time we are only doing 4 devices. This is the callback for the relays. We then give Alexa the names that will operate each device. In the setup we are going to initialize the LCD by first clearing anything that is on the display, and then setting all of the parameters for the display. The last line here will print when the display is ready to use. This next section is just something I wanted it to display after it was initialized. You will have a line that says, LCD1.set cursor 0,0 before your print line. This tells it to start the pint at the first column in the first row. If you don't do this before each line you print, it will place your next print after your last one. For example, you will see that every print line is preceded by a line that tells it where to print. Here we have set all of the relay pins to output. In this section we have set it so that on reset, all of the lights will be turned off. Also the LCD will display the lights are off. You will see that the first line tells the LCD its position to start printing the line. Just remember that the lines on a 20x4 starts at 0 and goes to 3. If you watched the last video, you should know this part, so let's move on. Remember that here in the loop, you must set a delay of at least 5 in order for Alexa to find all of your devices. Here in the callbacks, we have added these lines. First the line to set where the line will print, then the print line that says that light 1 is on. Look close and you will see there is a space at the end, before the closing quotation mark. The reason for this is if you look at the next print line, it prints on the same line and is 1 letter longer than the previous print line. When the light is turned back on, if not for the space, it would overwrite everything except the last F in the word off. As you can see, we did this for each light, placing the print lines 1 down for each light. Note, the 20x4 and the 16x2 lines and character spaces start at 0, not 1. This is the LCD we will be using. You will notice that we bent the pins straight. The reason for this is that it makes it easier to plug into the breadboard. Another reason is that I want to make this project modular. I want every part that goes bad, to be able to just unplug the bad part, and plug the new part in. Now we are going to put everything together. You see the ESP32 we are going to use, and this is the 8-channel relay. Here you can see the pins are facing down. When we got this, the pins were facing up, but we put new ones to make this part modular and able to plug into the breadboard. Time to put the wires on and program the ESP32. First, we connect the power wires. Let's connect the data pin and the clock for the LDC. Remember, the data pin goes to pin 21, and the clock goes to pin 22. Now we connect the wires that control the relays. So now let's upload the sketch and see what happens. You can see here that it uploaded the sketch and everything seems to be working, but we still need to test Alexa. Watch for the next part where we will be programming an ESP32 for 16 relays, and use an I2C multiplexer to have 4 I2C LCDs with the same address, and show the status of each relay. Please subscribe to the channel, and give us a thumbs up. Also please visit our GoFundMe campaign and donate whatever you can to keep the projects coming. If you watch our office, equipment is disappearing. We have to sell our equipment to give you more videos. Until next time, stay safe, stay healthy, and stay happy. Bye for now.